vertical curves. For change in the gradient in the roads, we will provide the vertical curves. Vertical curves will be divided basically in two types, summit curves and valley curves. First, we will discuss summit curve. Summit curve can be provided for two rising gradients or one rising and one flat gradient, rising and downward gradient, downward and downward gradient. For any of these, we can provide the summit curves. How we will decide whether the vertical curve is summit curve or valley curve? This point is called as PVI, point of vertical intersection. If it is above the ground surface, it will be called as summit curve. If it is below, it will be called as valley curve. Typical N is the deviation angle. The typical formula is N1 minus N2. N1 minus N2. Depending upon the condition, it will changes. Depending on the condition, it will changes. If you take, this is the typical form of vertical. One is rising gradient, one is falling gradient. N is N1 minus N2. Here we have the downward gradient. So the deviation angle N is equal to N1 plus N2. Now valley curve. If you see all the four diagrams, the point of vertical intersection is below the ground level. Here downward gradient and downward gradient, downward gradient and flat gradient, therefore N2 is 0, only minus N1. Here downward gradient and upward gradient. This is the typical form of valley curve. N is equal to minus N1 plus N2. Here upward gradient and upward gradient. For any these type of gradients, we can provide the valley curves. First, we have to detect whether PVI is above the ground level or below the ground level. Based on that, we will decide the summit curve or valley curve. Next, how we calculate the length of summit curve. Here, basically in summit curve, we have to calculate the length. Capital H and small h. This is SSD. We already discussed in the classes. H is height of the driver's eyesight and small h is height of the object. Capital H is 1.2 meters, small h will be 0.15 meters. Whenever vehicle is traveling through the gradient, the basic problem is sight distance. You will not see the whichever vehicle coming from the opposite direction. Summit curves will be designed for proper sight distances. How we calculate the length of summit curve? I told based on the sight distance. If it is SSD, one side will be capital H, one side will be small h. That is height of the object. If it is OSD, both sides will be the height of driver's eyesight. Here we have to assume again L is greater than SSD or L is smaller than SSD, or L is greater than OSD or ISD, or L is lesser than ISD or OSD. First, we will consider for L is greater than SSD. The formula is ns square divided by 4.4. Next, L is smaller than SSD. L is equal to 2s minus 4.4 divided by n, where n is the deviation angle and s is the sight distance. Similarly, if you go for the OSD, it is ns square divided by 9.6 and 2s minus 9.6 divided by n. Next, length of valley curve. In valley curve, we don't design for SSD or OSD. Why? Because whichever vehicle is coming in this downward direction, the driver has the clear visibility. The driver has the clear visibility whichever vehicle is coming in opposite direction or where he has to stop the vehicle. But what happens in the valley curve? We design it for, first one is comfort condition. We design for the comfort condition. Why we design for the comfort condition? As it is the circular curve, whenever the vehicle comes downwards, if it comes in the higher speed, it will impact. You will feel the impact in the value point. Why? Because again the centrifugal force will be acting here. So if the centrifugal force increases, then what happens? There will be the uncomfortability to the drivers and passengers. For the comfort condition, we have to calculate the length of valley curve. Here L is equal to 2 into root of nv cube divided by c. C is the centrifugal acceleration. And one more thing, again here we consider the side distance, that is headlight side distance. If the vehicle is on the top of the value point, he has to identify where is the bottom value point, and again when he has to go up. So for headlight side distance, we will design the length of valley curve. L is equal to n square divided by 1.5 plus 0.035 s if it is greater than the side distance, or L is smaller than the side distance. L is equal to 2s minus 1.5 plus 0.035 s divided by n. This is again I am telling, we have to assume the condition. The conditions may not be given in your problems. Let us solve the problems. A vertical summit curve is formed at the intersection of two gradient plus 3% and minus 5%. Design the summit curve for SSD. Design speed 80 kmph. As we know, SSD v square divided by 2gf, f is 0.35, t is 2.5. We get 128 meters. V will be in terms of meter per second. Deviation angle n1 minus n2 or n1 plus n2, we will get 0.08. First we will assume L is greater than SSD. How much we will get? 297 or 298 meter. The assumed condition is correct, so we will go for L is equal to 298 meters. Next, an ascending gradient 1 in 100 meters. It's a descending gradient 1 in 120. A summit curve is to be designed for 80 kmph. Here for OSD. For OSD, we will assume first greater than OSD, length of the curve is greater than OSD, 9.6, 422 meter, which is not greater than 4 centimeters. So we'll go for next. We'll assume L is lesser than OSD. How much will get? 417 meter. Next, a valley curve 1 in 25 and 1 in 30, designed for both comfort condition and HSD requirement. Here, by putting centrifugal acceleration directly, we can take L is equal to 0.38 root of nv cube. We can take 0.38 root of nv cube, we will get 73.1 meter. HSD for 80 kmph, you have to calculate HSD is equal to SSD. If you assume L is greater than SSD, you will get 199.5 meters, which is greater than SSD. So the length of valley curve is 200 meters. Here we have the major problem. A vertical summit curve is to be designed when two grades 1 in 50 and minus 1 in 80 meets on a highway. The SSD and overtaking side distance are 180 and 640 meters respectively. But due to the side conditions, the length of vertical is restricted to be maximum value of 500 meters. If possible, calculate length of summit curve for SSD, OSD, or at least ISD. First, we will calculate for SSD. SSD is 180 meters. We will assume L is greater than SSD. How much we will get? 239 or 240 meters. The condition satisfied. But the length available is 500 meters. So still we can go. L is greater than OSD, I will assume. I get 1387. The assumption is correct because OSD is 640 meters, but I am getting the length 1387. But as the length of the curve is restricted to 500 meters, it is not possible to provide the required OSD of 640 meters. So we will provide for ISD. ISD is 2 times of SSD, we will get 360 meters. For that, if we calculate n square divided by 9.6, it is around 440 meters, which is within the limit of 500 meters and above the side distance. So we'll provide the length of summit curve 440 meters.